Hello everyone, I'm excited to share with you my final project on Nepal Stock Exchange forecasting using Deep Learning LSTM model. Now let's get started with an overview of this project. I decided to use deep learning algorithm because they are excellent at handling time series data, which stock prices essentially are. LSTM type of deep learning model excels capturing long-term dependencies and patterns like in sequences of data, making it perfect for predicting stock prices. And for this project I trained LSTM model in four different ways, and they are like univariate forecasting, multivariate forecasting using technical indicators, multivariate forecasting, and multivariate multi-step forecasting. And finally, to assess the performance of these models, I use the key indicators such as RMSE, MAPE, MDAPE, and MAE, and the MAE. And this matrix, like why we use these matrices, because like these matrices help us to understand how accurate our prediction is. Now, let's begin with univariate forecasting. Now, in univariate forecasting, we can see like in first, yeah, importing required packages. Okay, uh, importing required packages like here we have imported packages like math which provides which is imported for mathematical functions, numpy for fundamental packages for scientific computing, pandas for um, analyzing and manipulating data, date time and time delta for date time function for uh, working with date and times, matplotlib for visualization, uh, and sklearn for to normalize the price of data, and so on. Now moving forward, like we have in this we have imported the data, we have imported the csv file, and here we have done data framing. Now here we have done the exploration of the data, and we have visualize the data, visualize the data of closing price against with the date. And we have done in this step we have done like in this step we have done mm, data splitation is done here in the ratio of 80-20, 80% for training and 20% for training testing. And here uh, we have splitted data for training and testing. And now moving forward, we can see here we have done data processing, and data processing is done to clean, transfer, and what prepare data for analysis, modeling, and what else for decision making, and to make better data quality. Now moving forward, we can see here we have done a data partition here, um, data partition. And now we have in this stage we have here we have um, we are building the LSTM model here. And moving forward, we can see the summary of the model. And here we are feeding the model to the training data with the epoch size of 50, which means that training data has been iterated for 50 times. And moving forward, we can see here we have done training and validation loss. We have done training and validation loss to prevent overfitting and to evaluate the performance of the model after. uh, Now moving forward, we can see uh, we have done prediction and checking performance matrices. And here we have transfer the data into the original form. And here we have done the Here we have done calculate the modal performance matrices, performance matrices of univariate forecasting. Here we have calculate RMSE, MAE, MAPE, MDAPE, and here we can see the uh, score of univariate forecasting for different technical for different technical indicators. Now here we have visualizes the score of the technical indicators that we have calculated above. Now here we have splitted the training data um, and predict the stock price, and we have shown the closing and predicted price along with the date. And here we have drawn training, testing and validation. We have plotted the trained, test and predicted values here along with the day along with the time from the of time frame of 2000 and 2024. And we have uh, we have plotted here like actual and predicted of test data here from 2018 to 2023. Now to test this model, we have imported new data set, that is SBL in CSV format. And we have now we have plotted this diagram, and moving forward we can see like mm, now here we have done like predicted the price of SBL for next 40 days, and these are the predicted price, and these are the predicted price. Okay, and now that's it for the univariate forecasting. And moving forward, let's move to the multivariate forecasting using technical indicators. In this model, many of the steps we have discussed above in univariate forecasting are repeated in this model. So for those activities we'll be skipping. And now we can see here, importing required packages, importing data, uh, navel.csv, exploring the data, and we are plotting the data. Okay, we have used the concept of feature engineering for data data processing process. And here we have done data framing, that we have done data pre-processing and feature selection. Yeah, same as like a previous data splitting in 70/30 ratio. Now uh, moving forward, data processing, here we have done a data partition in x and y axis. We have built the LSTM model in multivariate forecasting using technical indicators. Like we can see the model summary here, and we have fitting the model to the training size, keeping the 100 epoch size 100 and batch size 32. Okay, and we have done here trading and validation loss to prevent overfitting, and to calculate the performance of model. And here we have done a prediction and check the performance matrices, you know. And we have done here a performance of evaluation of multivariate forecasting using technical indicators. We can see the score like RMSE 56.94, like MAE 38.84, MEP 3.26, and MDAPE 2.5. Okay, and we have visualized the above score here. And we have and now this is our we have shown the price along with the predictions. Okay, predictions here. And here we have the plotted visualize the data with of training, validation and prediction. We have drawn here training was we have drawn compare the training, validation and prediction price. And here we have compare the actual and predicted of the projected values on on the basis of the testing data. And that's it for the um, multivariate for forecasting. Using technical indicators, let's move forward to the multivariate forecasting. Here we have imported the packages, and where we are importing the data in CSV format. We are data framing, exploring the data, same as above. And here we have data preprocessing, like data preprocessing and feature selection concept is used here. And we can see the you can see the data that here we have drawn this splitting in 70 to 30 format here. mm, 70 format, and after splitting, like this is the data set. And we have used the concept of pre-processing and data partition in x and y, same as above. Building Now we have built it LSTM model for multivariate forecasting. Multivariate forecasting, giving the size equal size of 100 and batch size 32. Now after running, like after fitting the model to this training data, we have calculated the training and validation loss, and we have discussed why we do our training and validation loss above. And we have calculate the performance of the multivariate forecasting. And we can see the different technical indicator score of multivariate forecasting, like RMSE 581.72, MAE 463.99, MEPE is 36.24, and MDAPE is 34.12, which is comparatively like good among like univariate and multivariate forecasting using technical indicators. Like here we have visualize the data. Here we have like we have shown the data along with the predicted data. And here we have shown compare the training, validation, and prediction data. And here we have here you have plotted the actual and predicted data against the date. And now to test the data, to test this model, we have imported another data set, that is SCB, like SCB data set in CSV format. And like we uploaded this diagram, okay, in visualize this. And we have filtered the data, and now same as above. Now we have in the last, we have predicted the price for next 30 days. And this is the this is output. Here we can see this is the output. uh, predicted stock price of new data set. Now data set is filtered in only the closed value is plotted here. uh, and forecasted closing price is plotted here along with the date. And we have compared the original and forecasted value here. And that's it for the multivariate forecasting. Now moving forward, let's move to the multivariate forecasting, multivariate multi-step forecasting. Like we have imported the packages. We have read the CSV files. Now this is our data set, plotting, visualizing the data, and and correlation is here, correlation matrix is shown here. Now now correlation between data frame and close volume is shown here. And this is our data, this is our data. And we have 4,928 data with 6 columns. And we have processed the data. Now here we have representation of preprocessed data. And we have here normalize the data. And normalize, and we have 4,928 data with 5 columns. And we have split the data for training and testing. Yeah, let's see how okay. And so now same as above, moving forward, let's go. And here we have configured the neural network model here, and we are training the model here, keeping the evo size 10 and batch size 64. We have kept the batch size like when fitting the model into training dataset, we have kept different each evo size for different models to see the different outputs. And after that we have plotted the training and validation loss. We have done a training and validation loss. We can see the training and validation loss, which is like critical loss against apples. As you can see that training data's loss is decreased along equal size is increased, and for validation data the loss is increased with increase in equal size. Okay. Mm, and now we have calculated the we have evaluated the multivariate multi-step forecasting here, and we can see the score of technical indicators here, like RMSE 283.53, MAE 198.32, MEP 17.73, MDAP 14.13. Okay, and we have visualized graphically and preprocessed data driven. And similarly there are like here we have uh, testing predicted and tested value here plotted. Now again we have importing to test this model. We have importing new csv file. Format is like this, plotting this diagram, and dataset is like 4928 rows and 6 columns. Proposes the new dataset. Now we'll be predicting like here. We'll be predicting like closing price here we can see, and uh, making comparison between univariate forecasting. Like till now we see the all the four models. Okay, univariate, multivariate forecasting using technical indicators, multivariate forecasting, and multivariate multi-step forecasting. And we are like here we have done the comparison. We have done the comparison on the basis of the different evaluation matrices like RMSE, MAE, MEP, MDAP, and we have plotted the diagram. Like we have visualize their like performance to like you know, for better readability. Okay, and we can see the RMSE score of different model. Okay, blue indicates univariate, green indicates multivariate using technical indicators, red indicates multivariate, and multivariate multi-step. And here we can see red is indicating a multivariate forecasting. Okay, and after like when we make a conclusion like uh, multivariate forecasting has performed the best across the all for performance. Okay, that's it. That's it for that's it the like NEPSE stock forecasting using deep learning. Thank you for your time. Have a good day.